Hey guys, Carl here from the Dublin Academy of Education, and I'd like to welcome you to our Junior Cert Maths Back to School course. Okay, so look, hope you've all done really well. A really strange second year. It's quite a tumultuous time, you know, you're all over the place since March. You might have had a couple of online classes with your teachers, and now really you need to get straight back into the swing of things as schools are reopening. So what I'm here to do to help you with is to kind of get you back into the swing of things, and what I'm going to do is I'm going to spend some time with you looking at the whole area of trigonometry. So really what we want to do is we want to make sure that when you're finished with this online course, when we've gone through all of this, that you're going to have a certain section of the exam completely boxed off. Now the area that we're going to do, as I said, is trigonometry. Trigonometry is worth 5 to 7% of the exam. When we're finished this course, it's going to be like, yes, I now have 5 to 7% of the exam. So you're already getting a head start on your friends that are going back to school with you. Ultimately, you've got an exam to do, and we're going to talk about that. And the reason why you're tuning in is that exam. So we've got to start as early as we possibly can. We want to get a head start. We want to make sure that we can get the ground running straight away when we get back to school. And really, that's the aim and that's the objective of this back to school course. So before we get into that whole area of trigonometry, really what I should do is I should introduce myself. So my name is Carl. I am now teaching here in 8 years. So I joined the academy in 2012. I'm one of the longest members of staff here, one of the youngest looking, but one of the longest members. And I've been teaching since 2002. So I'm in my 18th year of teaching, which is absolutely crazy. Now, what you'll basically get within this back to school course, this online course, is to get you a taster of what our classes are like. Now, what we'll try to do is, obviously we know the situation that you're in. Most students, they don't like maths, they don't like the teacher, so we try to make it as kind of pain-free and as enjoyable as we possibly can for you. So within this back to school course, I'll give you a taster of what our weekly classes are like. And as I said, we're going to make them as enjoyable as possible. We give you tips, we help you with the exam, we give you kind of strategies that you'll use to implement when you go into any exam question. And when we actually get onto the trigonometry area, we'll look at those strategies. You know, what are the tips that we need, or what are the tips that we could use when we approach these type of exam questions? So, as I said, you probably don't need to know too much more about me. You'll get to know me a little bit more within the weekly classes, but that's me for now. And I'll come back and talk a little bit about maybe myself later on. So that's me. And that's a little bit of the introduction. Now what I'm going to do is I'm going to spend a couple of minutes talking about what we actually do within our classes. You know, what is it that we offer? What can we give you? How will these classes actually benefit you? So really when I think about my classes, I think about them in three main areas. And the three main areas we think about is in terms of the exam, the notes, and you as the students. Like, why are you tuning in here, apart from your parents forcing you to do it? Why are your parents asking you to tune in? Because ultimately you're going to have an exam to do. Now, last year's third years, fortunately, didn't have an exam to do. For loads of reasons, the main reason being COVID, they couldn't do the exam, and obviously their teachers then had to examine them. But I can guarantee you, in 2021, you're going to be doing the junior cycle exam. And what I'm here to do is, I'm here to prepare you for that junior cycle exam. I'm here to give you the tools that you need, the resources that you need in order to excel in that exam. And that's what I'm going to do. So what we'll do is we'll only concentrate on the type of questions that we think the examiner is going to ask in 2021. And we give you everything that you need to maximize your potential, to maximize your grade in that exam. So that is our main philosophy in here. Make sure that every student maximizes their potential. So I'm here to individually and as a group to give you everything that you need to maximize your potential and get the highest grade as you possibly can in that exam. Ultimately, that's why you're tuning in now. That is why you're going to attend our classes. So we're here, as I said, to give you everything that you need to maximize your potential to get your highest grade that you possibly can in the exam. And that's what we do here within the Dublin Academy of Education. So that's the first area that we look at. We're having a look at the actual exam focus. Now, second area, notes. So you are the first year now to do the new junior cycle maths exam. And the junior cycle maths exam has 5 strands. One of the strands being a bit of a strange one, a unifying strand. And what we are going to do is we're going to give you a set of notes based on all of those strands. So we'll give you sets of notes based on algebra and functions. We'll give you sets of notes based on trigonometry and geometry. And they're your main resource for the year. They act like your Bible for the year. You've got all of the course content within those notes, and what we'll also provide you with is a load of exam questions. And ultimately, for you to excel in the exam, it's all about you practicing those exam questions, trying to do as many of those exam questions as you possibly can. So we'll give you loads and loads of exam questions, and with those exam questions, we'll also give you solutions to those exam questions. Because sometimes you can use the actual notes as a standalone study tool. Within the classes, within the weekly classes, I'll be going through the notes and going through the questions and going through the solutions with you. But you can use them as a standalone study tool. Now, sometimes you can't answer the questions, and if you can't answer the questions, we need solutions with them. It's a bit like, you go into school, your teacher gives you a question to do, you can't do it, what do you tend to do? You go to the back of the book and you write down the answer. And we don't give you answers, we give you solutions, because the solutions act as the stepping stone. How you start at part A, you're here at part A, how can I get to part A? So we're using the solutions as a route or as a map to get to the answer, and we'll provide those within the actual notes. So as I said, you'll work through you'll work through the notes with me in the weekly classes, but you'll also use those as a standalone study tool. And then finally, I'm always conscious of you. What do you want? How can you excel? And ultimately, I'm here, as I said, to make sure that you maximize your potential. Now, the way I always think about it is, I'm not here to teach you maths. I've got to be careful with this. I'm not here to teach you maths, but I'm here to teach you how to answer the maths questions that come up in the exam. That's what we're trying to do. We're providing you with the skills that you need to answer the exam questions. So we're only interested in the type of questions that the examiner will ask. And we'll look at each of those questions and we'll make sure that you're as efficient in those questions as we possibly can. That's what we're here for. So I'm like, we need to know this question. This is such a common question that comes up. We need to know this question. This is very, very common. That question, not as regular, not as common. If there was one area that I was leaving out, that would be the one area that I'd leave out. So we're here to make predictions in terms of what we expect to come up in the exam in June 2021. But ultimately, I'm only here because you are here. So I am here to help you. So the classes next year, we've got these nice small classes where everyone can ask questions, everyone can get engaged. It's interactive. We try to make it as interactive as possible. We don't want boring classes. We don't want classes where, students are, oh Jesus, I have to do this. We're here to make sure that you enjoy the classes and to give you the tools that you need in order to excel in the exam. And that's what we're going to do. So they're the areas that I would always concentrate on within my particular classes, and that's the type of areas that you'll see within the weekly classes. That's what we'll try to offer, all right? Or that's what we do offer. Now, as I said, what I want to do is I want to make sure that the fact that you're tuning in, that we're going to get some particular percentage of the exam done. And as I said, we are going to have a look at trigonometry. So you will have received 2 sets of notes. You'll receive this one here, which is the 3rd year maths higher level Carl Brien trigonometry. You'll receive that, which I'm going to get onto in a couple of minutes. But you'll also receive this Holy Grail sets of notes. Alright? Now, the Holy Grail, for me, this is really a standalone study tool for you. I'm not going to spend time going through it. If you look at the second page on it, you've got your table of contents. You've got your information on the exam layout, your information on the marking scheme, past exam questions appearance table, and then obviously the syllabus checklist. So there are areas that that will help you. If you study those, you'll see there's different areas there that will help you when you're approaching the exam, when you're approaching your mocks and when you're approaching the exam. The one area that I really want to just talk about within this particular video is the information on the marking scheme. And really the area that I'm going to talk about here is the importance of you actually doing something in the exam. You've got to show the examiner that you understand exactly what he's asking you to do. And there's so many ways that you can pick up easy marks in the actual exam. So for example, there was a question asked a number of years ago, and it was a quadratic equation. Now, with our quadratic equation, if we had something like this, solve 3x squared plus 11x is equal to 4. And you were asked to solve that quadratic equation. And by the way, since Project Maths was introduced, quadratic equations are asked every single year. So we need to know how to solve them. We could either factorize or we could use the minus b formula. So a lot of students, if you can instantly recognize that this here is a quadratic equation, and there is a formula to solve quadratic equations, and the formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. If you just wrote the actual formula in the examiner gave you 4 marks out of 10. So in the exam, there is a huge amount of questions that are based on formula. Right? So a huge amount that are based on formula. So the first thing that I would always ask you to do is when you go to the exam and if the question is based on formula, first thing you always do is write down the formula. Now next year, when you're doing your exam next year, there is only one paper. Okay, there's only one paper. Traditionally, there was always 2 papers, paper 1 and paper 2. And if you think about traditionally the areas that were examined in paper 2, so areas that are examined in paper 2, area and volume. You know, what is the volume of the sphere? What's the volume of the cylinder? And so on. All formula based. Right? So all formula based, first thing you'd always do, you'd write down the formula. The line. So what's the distance? What's the midpoint? What's the slope? What's the equation of the line? All formula. We're going to have a look at trigonometry. And I'll give you a strategy with trigonometry, but ultimately, it's 2 formulas. If we think of geometry, we can apply our formulas to that. We've got statistics within this area. Like statistics, one thing that you're asked quite regularly is to find the mean. The mean is based on a formula. So you'll see that within the Holy Grail notes, I'm giving you tips on how to pick up easy marks. But one of the tips that I always give you is if it's based on formula, always write down the formula. It is so important that you do that. Go and actually write down the formula. Right? It's essential that you do that. A huge number of questions are based on substitution as well. Substitution, I mean taking a value and substituting it into an equation. And if you do that, what will the examiner do? He'll give you marks for that. So there's ways that we can pick up easy marks in the exam, and we want to be able to do that within the exam. We don't want to lose simple marks. We don't want to lose silly marks. We want to pick up these easy marks, and within the Holy Grail, you will see examples of that in there, and please use that as a standalone study tool. Have a read of it, go through it. You'll see we've got past exam questions appearance table. We don't have it for 2020, we don't have it for 2020 obviously because we didn't have a 2020 exam. And we also have a syllabus checklist, so as you're studying, as you're revising the different areas, you can just go along, tick off, and make sure then that can be used as a study tool. Okay? So, that's a little bit of information about me, it's a little bit of information about the classes, and it's a little bit of information about the Holy Grail. And as I said, I want to make sure that for you tuning into these classes, that we'll cover a certain area of the course, and the area that we're going to cover now is trigonometry. So what I would like you to do, we're going to make this as interactive as we can. Can you just make sure that you have your trigonometry notes at hand, and we are going to work through these trigonometry notes. So, you see there, 3rd year maths, higher level, Carl Brien trigonometry. It's the back to school online courses. And then on page 2, there's a little bit of information about the actual classes. So what do we cover during the year? Will you get a set of notes? When are the classes? You've got the timetable classes. We've got class on a Tuesday, class on a Thursday, class on a Saturday. Can you go into other classes? Will there be homework and so on? So for yourself, just gives you a little bit of information on page 2. Have a little read of it. And now let's get straight into our trigonometry. Now as you can see on the top of page 3, it says trig is worth 5 to 7% of the junior cycle exam. It's going to appear across the paper, and then we've got different areas that we're going to have a look at. Now what we have in the table of contents is we have Pythagoras, sin, cos, tan, minutes, angles of elevation, angles of depression, from one to another, evaluating trig functions, and past and probable exam questions. Now, what I'm going to say is, ultimately, every question comes back to 1 and 2. We've got to know Pythagoras, and we have to know our trig functions of sin, cos, tan. You must know these. Okay, so the main areas on the syllabus are these 2. Ultimately, an exam question will be based on those 2. Right? Now, you're probably saying, well, Carl, why do you have the other areas within the actual notes? The other areas, like angles of elevation and angles of depression, actually go back to using his. Okay, but ultimately, these are the 2 areas that you need to know. Now, what I would always say is to have a strategy for trigonometry. Now, this is your strategy. Don't forget this, and I'll keep going through it within this back to school course. Okay, this is the strategy. So, 1, you recognise that it's a trigonometry question. So if you're in the exam, how would you be like, yeah, this is a trigonometry question? You'll recognise it because the examiner will give you a right angle triangle. Okay, so once the examiner gives you a right angle triangle, the alarm bells are going off. You're like, yes, it's trig. And if it is trig, it's either these two, Pythagoras or sin cos tan. So you're asking yourself, could I use Pythagoras or could I use sin cos tan? So ultimately what happens is the examiner will give us 3 pieces of information in the triangle, in the right angle triangle, and we'll ask ourselves, can we use Pythagoras or can we use sin cos tan? So when did you use Pythagoras, or when do you use Pythagoras? We use Pythagoras to find the third side of a right angle triangle when we're given 2 sides. That's the general rule. And there is a formula for that. And I said to you, if we're given a formula, if we're working with a formula, what should we always do? We should always write down the formula. So the formula is c squared equals a squared plus b squared. Alright, so c squared equals a squared plus b squared. And c is always the longest side. And the longest side is always opposite the right angle. Now we do have to be able to label the sides of our right angle triangle, but I'm going to wait to do that in sin cos tan. With Pythagoras, ultimately, all we're doing is using a small little formula, c squared equals a squared plus b squared, and always remember that c is our longest side. Now that's when we use Pythagoras, to find a side in a right angle triangle. When do we use sin cos tan? Well, these are our trigonometric functions. There are trigonometric ratios that allow us to find sides or angles in right angle triangles. Right? So that's what they allow us to do. And teachers will have different methods of remembering whether to use sin, cos, or tan. And you'll see in the notes that the method that I would use is sa, ca, ta. Alright? And I'll get to that in a couple of minutes. But ultimately, every question is going to come back around to these two. And once we remember that, we're absolutely laughing. And we're going to apply that knowledge to some of the actual questions. Well, actually to all of the questions. So, let's get straight into Pythagoras. Let's turn to page 4. And there's a little bit of kind of course content, syllabus content on that. So again, it's c squared equals a squared plus b squared. And as we said, c is the longest side. So the longest side squared equals the other side squared plus the other side squared. And that's on page 4. Make sure you know your properties of triangles. You know, our properties of triangles. What do we know about our triangles? Well, we should know that our biggest side is, or our longest side maybe I should say, our longest side is always opposite our biggest angle. And our smallest side is always opposite our smallest angle. And that's why when we apply that to a right angle triangle, the biggest angle is the right angle, and you can clearly see that that must be the longest side there, it's opposite that. Okay, so we apply it to our actually right angle triangle. So know your properties of triangles, which you would have done in geometry. So, based on Pythagoras then, if we go to page 5, we're asked to find certain lengths here in right angle triangles. So again, instantly you're saying to yourself, it's a right angle triangle. If it's a right angle triangle, it's trigonometry. If it's trigonometry, it's either Pythagoras or sin cos tan. And then ask yourself, can I use Pythagoras? Or can I use sin cos tan? So if you look at example 1, it says find the length of x. We've got a right angle triangle there. I'll just put it here. Right, so example 1. This is our right angle triangle. We have 3, 4, and we have x. It's right angled, and you're saying to yourself, oh, right angle must be trigonometry. If it's trigonometry, it's either Pythagoras or sin cos tan. Pythagoras were used to find sides in right angle triangles when we're given 2 sides. Not always. I'll talk about right angled isosceles in a sec. But you'd be saying to yourself, yeah, lovely, that's just Pythagoras. And the first thing we'll do is we write down the formula. So c squared equals a squared plus b squared. And we know that c is always the longest side. So what's the longest side here? Well, it's opposite the right angle, so it's x. So x squared equals 3 squared plus 4 squared. So x squared is equal to 9 plus 16. So x squared is equal to 25. Now we don't want x squared, we want x. How do we get rid of a squared? Well, we have to get a square root. So we get the square root of both sides, and we say that x is equal to 5. Lovely, right? No problem at all. Example 2 is the same. Let's have a look at example 3. Example 3 says find z in surd form. So what is a surd? A surd is a square root that doesn't simplify to a natural number, right? So it's not going to actually simplify for us. So we're given a right angle triangle, and if it's a right angle triangle, it's trigonometry, so it's either Pythagoras or sin cos tan. So we've got 7, we have 4, and we have z. and we want to find that z. So we, again, trigonometry must be Pythagoras. What we do, we'll write down the formula. So the formula is c squared equals a squared plus b squared. Remember, the c is always the longest side, and in this case the longest side must be 7. So 7 squared equals 4 squared plus z squared. So 49 is equal to 33 plus z squared. Now we want to isolate that z. We want to get that z on its own, so we're going to have to subtract 33 on both sides. And when we do that, we're going to get 49, sorry, that's 16. So it's 49 is equal to 16 plus z squared. We want to subtract 16 on both sides, and when we subtract 16 on both sides, we get 33. So 33 is equal to z squared. And then finally, what do we want to do? Well, we want to go and get the square root of both sides. So z is equal to the square root of 33. Okay, so z is equal to the square root of 33. And we're done. Simple, right? Very, very, very straightforward. Now, there's one or two more questions there. Let's have a look at the ones on page 6. In example 4, it says ABC is an isosceles triangle. Now, what is isosceles? Isosceles means two sides are the same, right? So within the triangle, two sides are the same, two angles are the same. So ABC is an isosceles triangle with AC is equal to BC. The distance from A to B is equal to the square root of 72, and the angle ACB is equal to 90 degrees. So it's a right-angled isosceles. Now, this was very similar to the 2017 exam, right? The 2017 exam question. There's a question on the 2017 exam that was very, very similar to this. And we're asked to find BC. So if I was just to draw this, right, example 4, we've got this. And we know that this is the square root of 72. And we know that this is A, C, and B. And we're asked to find BC. Now it's right angled. So we're asked to find this distance here. Okay? But because it's a right angled isosceles, the distance from C to B is the same as the distance from C to A. Okay, so the distance from C to B is the same as the distance from C to A. So if we call C to B x, it must also mean that C to A is also x. Now normally when we're using Pythagoras, we need to have two sides. But we don't need two sides when it's a right-angled isosceles, which it is here. Okay? So we're going to use Pythagoras again. When we're using Pythagoras, we'll write the formula, c squared equals a squared plus b squared. Now remember, c is the longest side, and you can clearly see the longest side is opposite the right angle, so that's the square root of 72. So the square root of 72, we've got to square that, equals a, which is x, we've got to square that, and then b, which is also x. Now what happens when we square a square root? They're going to cancel. So we've got 72 equals x squared plus x squared, which is 2x squareds. Now remember, what do we want on its own? What do we want to isolate? We want to isolate x. We want this x on its own. Now to get x on its own, what are we going to have to do? We're going to have to divide both sides by 2. We've got to get rid of that. And if we divide both sides by 2, we're going to get 36 here, and we're going to get x squared there. And then again, we've done this already. How do we get rid of that squared? What do we need to do? We need to go and get the square root. So we get the square root of both sides, and we can see that x is equal to 36. Okay, sorry, x is equal to 6. Okay, so x is equal to 6. Okay, so fairly straightforward, but again, we're just using Pythagoras. Now we'll do one more. Have a look at at the bottom of page 6, we've got example 5. Right, we've got example 5. And example 5 says, the lengths of the sides of a right angled triangle are as shown in the diagram. It says, using the theorem of Pythagoras, write an equation x. So the equation that we have is this. Now we're told to use Pythagoras. We don't even have to use our strategy of right angle triangle, trigonometry, Pythagoras, or sin cos tan. But we're told that this is 2x plus 2, and we're told that this is x plus 2, and we're told that this is x plus 1. And it says, using the theorem of Pythagoras, write an equation in x. Okay, so what did Pythagoras say? He said the c squared is equal to a squared plus b squared. And we're making it as easy as possible. The longest side squared equals the other side squared plus the other side squared. Now in this case, what is the longest side? The longest side is 2x plus 2. So we're going to have 2x plus 2, and we're going to have to square that. And that is equal to x plus 2, and we're going to have to square that, plus x plus 1, and we're going to have to square that. Now we'll go and simplify it, right? We'll go and simplify that, but just look underneath part 2. Part 2 says, solve this equation to find x correct to 2 decimal places. Now, telling you now, If the examiner next year, in 2021, if the examiner says solve it correct in 1, 2, 3 decimal places, you're always looking, if I just come back over here, we're always looking to use the quadratic equation formula. Now when we're using the quadratic equation formula, our equation needs to look like this. ax squared plus bx plus c is equal to 0. And then we've got our a or b or c. Our a is the value in front of x squared, our b is the value in front of x, and our c is our constant. But what we need to do is we need to take this equation here and make it look like that. So we'd have to go and multiply that out. And when we square something, what does that mean? It means to multiply it by itself. So what we'll have is 2x plus 2 by 2x plus 2 equals x plus 2 by x plus 2 plus x plus 1 by x plus 1. Now you take your time in a question like this, you know. Some of your teachers might get you to rewrite this. I wouldn't, I would just use arrows. But we just got to be careful when we're multiplying them out. I always think of like SNL, right? So when you're multiplying out, when you're expanding in algebra, so signs, numbers, letters. Look after the sign, look after the number, look after the letter, right? So we're going positive plus positive is positive, 2 by 2 is 4, x by x is x squared. You know, that's the way I would do it. You know, make it as easy for yourself as you possibly can. Then we're going 2x by 2, and that has to be 4x, 2 by 2x, and that has to be 4x, and 2 by 2, that has to be 4. Take your time. That is equal to x by x is x squared, x by 2 is 2x, 2 by x is 2x, and 2 by 2 is 4. And then finally the last set of brackets that we need to expand, x by x is x squared, x by 1 is x, 1 by x is x, and 1 by 1 is 1. And we just tidy it up, right? So add the like terms, you know, don't lose your head here. It looks like there's loads going on, but it's actually grand. Tidy up the left hand side and tidy up the right hand side and then bring everything together. So we've got 4x squared, we have 4x plus 4x, and that's obviously 8x, and that's plus 4, and that is equal to x squared plus x squared, that's 2x squared. And just be careful here, we've got 2x plus 2x, which is 4x, plus x is 5x, plus another x is 6x, so plus 6x. And then we have a 4 plus a 1, which is 5. And then all we've got to do is get everything to one side. So what we'll do is we'll bring the right hand side over to the left hand side. Right? That's what we're going to do. But when we bring those over, that plus 2x squared becomes minus, that plus 6x becomes minus, and that plus 5 becomes minus. So 4x squared minus 2x squared is 2x squared. 8x minus 6x is 2x. And then finally 4 minus 5 is minus 1. That is equal to 0. And that there is our quadratic there. So when we're putting this, when we're using the quadratic equation formula, what is our a? What's our value in front of x squared? It's 2. What is our b? What's the value in front of our value in front of x? It's 2. And what's the constant c? It's minus 1. So a2, b2, c minus 1. And I'd imagine that you have done quadratic equations. Now you may not have, because as I said previously, there might be a lot of areas that you might have missed in second year as a result of COVID-19, as a result of the shutdown of the schools. That is one thing that you definitely need to know. You need to be able to use the minus b formula. You will be doing it with me in the weekly classes. Now it's an area that's examined all the time. Literally every year it comes up. So it's an area that we definitely need to know. Okay, so that's an area that we definitely need to know. And we need to apply the actual formula. We need to take those values and we'll stick them into the actual equation. Okay? Right, but again, remember it says solve correct to 2 decimal places, and when you see 2 decimal places, you're automatically thinking, I'll just come back over here, you're thinking that minus b formula. That's what you need to know. Okay? Right, so that's pretty much Pythagoras. Right? It's using that formula c squared is equal to a squared plus b squared, but this strategy really important. Right angle triangle, trigonometry. If it's trigonometry, it's either Pythagoras or sin cos tan. That's Pythagoras done. Let's turn to page 8 and let's start looking at sin cos tan.